Okay, let us go ahead and get ourselves started today. Today we have, hopefully it's going to be a pretty fun session to go on. We are going to continue looking at some of the different things that we were looking at last time in terms of taking images and trying to come up with efficient ways of processing them and using some kind of special features that are available within the scripting environment to create some custom nodes to make some of what we're doing a little more repeatable. And hopefully not so strung out across these big maps of all the different nodes. So it'll be a little bit easier to understand, share with other people, and reuse. So we'll be taking a look at that, as well as finally today getting around to creating that parametric stadium I've been promising. So we're going to go ahead and take a look at that to hopefully use some of all this scripting and all this parametric control to start seeing how you can start creating true architectural forms very, very quickly. To get started today, if you can, please download the Session 9 Dynamo examples. We will go ahead and use those throughout the session to kind of just keep you caught up with different things. So if you can, that'll be super. As we get going today, let me just kind of start by asking if there's any questions about the assignment, or if that sort of makes sense. I guess what, Mr. TAs, are we having office hours tonight, or how's this working?
Yeah, tomorrow and on Tuesday.
Tomorrow and on Tuesday? Very good. So there's some announcement about that?
Yeah.
Very good. Okay. Any questions about it just going into it, about what the intent is, or has anyone started it yet, or you start still thinking about it? It's more on the thinking side. It's a busy time. I understand. Okay, no worries. Big thing is you're just going to go ahead and grab any image at all that you would like to use, and just use it to grab color values out of, sample it, and hopefully what we're doing today will kind of continue to kind of build up your understanding of what you need to do or how to approach it very efficiently. So as we think back to what we did last time, I spent a lot of time looking at how we create parametric elements and parametric panels, adapt them. We'll be using a lot of that as we start building this parametric stadium. We'll take a look at the different pieces that we have available and think about how we can adapt them if we need to go through and be able to create different forms. Before we get into the parametric stadium, though, I want to go ahead and just look at a couple more nuances of that whole issue of mapping these panels to these image colors and how to use that. We'll open up that 9.1, what we did last time, again, just briefly, but I want to then move into really showing you how you can do it a little more efficiently. So let us go ahead and get started. Any questions as we get going? You ready? Okay, then let us move on over to Revit. And what I'm going to do is start by just opening that example 9.1. So under Session 9, the Dynamo examples, go for 9.1. And you'll see, oh, there is that funky little surface hanging out there. It has an image loaded on it right now. And let's just take a look at some of the Dynamo scripting and really what we had to do to it. Okay, what I'll do is go to the add-in and open up Dynamo. Then we'll open the Dynamo file that works for this one. Go to Session 9. I'm going to go for 9.1 end. Since it's already strung together, we can take a look at it. So again, the big piece about this that really makes it all hang together is this notion of you're just going to go out there and find some sort of image file. You can use the file path node to go through and do that. And you can go ahead and just choose any image file out there on your hard drive. Just saying browse. You head on out there, grab some image file you want, and then kind of plug it in there. And then when we evaluate it, we'll actually use this node, this read image file, which includes a num_x, a number y, as different numbers of points to sample from the file, and to kind of generate and read just a whole bunch of different color values. Let's just run that real quickly. Okay, now that we've run that, we can actually see that it's read the image file in, and let's take a look at the data that it's actually returned. So out of the image file, we get a big flat list. This is very much like where we had left it at the end of the last session. It's a big list of all the different data values, the RGB values for each of those different points. And let's, like we did last time, take a look at just how that list is compiled so you get a sense of really the order in which things are being presented. Let me switch over to this preview and show you the order in which the data is read. It's read from the lower right-hand corner across the row, then moving up to a second row from right to left, and up to a third row from right to left. And that's really the essence of what we have to sort of fight with, is that the way that the data is read and sampled from the image file is actually just reversed horizontally from the way we want to actually map it to our surface. So we're looking at something that's flipped horizontally, and we want to go through and fix that. Now, the way to fix that we talked about last time is to actually put a little bit of order in that list. So we'll start by just grabbing the rows, so 0 through 5, elements 0 through 5, taking that unordered list, or that list, excuse me, that grouped list, and breaking it into groups of 6 elements, because that's the number of elements in each of the different rows. And what we'll end up with is really, 3 different groups within that total list. So there'll be a list of 3 different groups, and within each of those different groups, there are going to be 6 points. Okay, let's go ahead and take a look at see how that happens. Pardon me. Okay, so what we're going to do is actually make use of something called the partition function. And in the partition function, what we're going to do is go through, give it the list of points, the list that doesn't have any grouping to it, and the partition is going to break it into groups. And to break it, what we're going to use is the V count. That's the number of different cells that are across an individual row. So we're going to go ahead and feed it 6. When we go through and run that, you'll see what it does is it gives us a list of 3 different groupings, and each of those different groupings have 6 different items in them. Okay, so those correspond to the rows. Okay, and that would work out just fine, except what we actually need to do isn't flip the rows, we need to flip the columns. Okay, so we're going to do a little bit of a transpose on that. And again, here's how that works. What we do is we take the row items and we'll just pair up the first item in each row, 0, 6, and 12 in this image. Okay, call that a group. Then we'll pair up 1, 7, 13 and call that a group. 2, 8, 14 and call that a group. So what we're going to end up with is, as opposed to 3 groups with 6 elements in each of the different groups, we want to basically get 6 different groups with 3 different elements in each of them. And that's what the transpose function is all about. So transpose just takes that and reorients things. And if you go to the transpose, you'll actually see that we have, 6 different lists, each of which have 3 different items in them. Okay, super. So now that we have our different lists that are representing each of the different columns, we can go ahead and flip that around. We did that as we did last time with the reverse function. That just takes all the different items in this list, okay, and reverses the order of the elements in the list. So the first column is going to become the last column. The last column is going to become the first one. So that just reverses the order of the different columns in the list. So what's going to happen in this list, okay, where the 6 different columns, each containing 3 points. The first one has a value of, just as a reference, 158 as one of the points, the first point in the list, and 83 at the back end. Okay. If we look at the reverse, you'll see it's the 83 at the front and 158 at the back. So that's just really flipped the order of the column. Now, once we have all the different columns in the right order, we do need to go ahead and actually flatten that list back out again, like we did last time, just to go through and make sure that we can map it back to the values that are needed for all the different adaptive panels. So what we're going to do is go ahead and retranspose the list. This is just going to rearrange them from that column order back into the row order, and then flatten that back out into one long flat list of all the different values. And by going through and doing that function, what we're doing is just really changing the order of the columns, and that's turned out to be a pretty useful function. So hopefully, okay, you see how that works, and we'll be able to use that to go ahead and really mirror or horizontally flip any image. Okay, we could also go through and do something to just flip the rows. If we were going to flip the image vertically, we would just go through and still slice it into rows, but we wouldn't need to transpose it. We could go ahead and just take this partition list, okay, go through and rather than transposing it, just reverse the order, and then we won't need to retranspose it and flatten it out. So flipping things vertically, at least the way our order data is given to us by the color sampling function, is actually a fairly easy thing to do. But let's show you how you can do that and actually create some custom nodes to do that, because it's really an incredibly useful thing to do. This notion of being able to take a big list of values and either flip the values as a grid horizontally or flip them vertically is a very useful kind of primitive that you'd love to have in your library to be able to share with other people, because it's such a useful thing to do. And to do something like that, we're going to go through and create something called a custom node. Okay, and custom nodes are really just like macros, where you have inputs, you have outputs, and you're able to go through and just feed things through that list very, very quickly. And let me show you an example of how that could work. So for example, we could go ahead and say that we want to create a new custom node. And what this is going to be is just defining a function that we are going to then be reusing. And for that, let me go ahead and say that we'll call it something like, kind of flip a grid horizontally. Okay, so flips a grid of points horizontally. Okay. We also can give our node a category. This category just really determines where it's going to show up over in the library, over on the left-hand side. So when you're searching for it, you can give it a little bit of hierarchy. For example, I can call it CEE 120. Okay. And, we can even call it session 9, since it's something we're doing for this session. Put it in there. Oops. Let's try that again. CEE 120. Say OK. And now you'll see that we actually have a little space down there for our flip grid horizontally. So now it's time to actually go through and define our custom node. And how we do that's actually pretty straightforward. You're going to recognize this because it really works just the same way we have been working so far. We're going to go ahead and use our partition list, just like we did. We're going to take that partition list and we are going to go through and what's next? We're going to transpose it. After we transpose it, we're going to reverse it. This is just drawing on exactly what we were doing last time. Then finally, I'm going to retranspose that. I could copy and paste that, but I'm just going to pull it out of the library again. Okay. And finally, with that retransposed list, I'm going to do something called flattening it completely. That'll make it a big flat list again. Okay, we got a good looking function here. We'd like to go ahead and reuse this. The only thing we need to do now to really make it useful is we need to indicate really where the starting points and the ending points are. And there's going to be two very useful nodes we're going to learn about. One called input and one called output. And that's how we basically feed values in and get values out. So let me go ahead and put output there too. And we'll go ahead and take a look at those. So here's how it works. The inputs can really just be the different values that you're going to feed in and how those should be advertised. Okay, should be just indicated here just with a text string that will help you recognize it within the node. So for example, if that list is here, we could say that we want to put list to flip here horizontally if I really want to make very explicit. And then what I want to do here is basically say, the value here would be the number of elements in each row. And again, these values, I'm being very verbose here to be very explicit about what I want, but they can be very simple too. The output is just going to be the list coming out the back end. Super. So we have a fantastic function designed. We are ready to use this function. Let me just go ahead and save this away. I can save it either in the main library. A better place to save it actually is in the same folder with the scripts that are going to be using the function. So I'm going to put flip grid horizontally just here in the same folder as the example. When it comes time to use your custom node, it needs to be able to find it. So it'll find it if it's in the same folder. Okay, and we are ready now to go back over here. So we have this function. Okay, what we are going to do is swap out in place of all these different nodes our function. It should really have the same effect. Put our custom node in here. So here's how we're going to do that. We'll just take our custom node. I could just drag it on in there, or click it in there, excuse me. You'll see it looks amazingly similar. It has the different input values and the output values. We will basically wire it up just the same way we would wire it. So I'm going to wire from the number of elements in each row, okay, to that input variable. I'm going to wire in the image file contents as the list to be flipped. Okay, at the tail end of this, we want it to really have exactly the same values as that big string, and let's see if it does. Let's say watch. Set up a little watcher for ourselves. We can watch that list that came out of all the kind of individual nodes. We can watch the list that came out of our custom function, our custom node function. Let's give it a run. And you'll see that it really does match. There's like a one-to-one correspondence, so super. The idea of really creating these custom nodes is that you can then go through and save these, share them with each other, reuse them between your different project files. It just gives you a way of creating macro functions, macro nodes, that will save you the trouble of having to go through and put these entire networks together every time. Okay. It'll also just make it a whole lot easier to kind of keep your work organized and keep your different programming networks just a little bit cleaner. So I could just take that and wire that in here instead. Okay, let's go ahead and close that one up. Or actually, what I want to do is just open up. I won't save those changes because what I want to do is just open up one where I already had it wired in for you. Just kind of show you that. In this case, we had already defined a couple of different custom nodes. There's one called mirror horizontal, and there's one called mirror vertical. And if we want to take a look at the programming inside those nodes, what you need to do is just right-click on it, and you can say edit the custom node. Okay, and you can get back to the node programming behind it. So mirroring horizontal, including the transposes on either side of the reverse, just to kind of get the columns as opposed to only getting the rows. But if we want to mirror something vertically, a little bit simpler still, we can just go ahead and let me edit that one. Oops, I got the properties that time. Let me edit it instead. Okay. You'll see that one looks very much the same. We're going to partition the list by the number of elements in each row, just reverse it and flatten it back out. So it's just a little bit simpler as a function goes. And now we have different functions for going through and mirroring, horizontally mirroring vertically. So the next thing to talk about is how can we wire this together with some if statements and some booleans so we can control which of these different operations are happening and control that, make it happen very fluidly. Okay, so let's turn our attention to that. Just open up the next example. I think it's called 9.2. Because you'll see it actually in place. What does it actually look like when you work with it? So go to mapping panels with custom nodes. Beautiful. Let's go to that one. Actually, go to the start one. We'll go for that. So basically, what we have in this version is we have a couple custom nodes already defined. There's one called mirror horizontal. There's one called mirror vertical. Let's talk about these functions and how they actually show up. Like mirror horizontal is not a bad little function. Mirror vertical is not a bad little function. Right now they're living in my world. They only live in my world. If I'd like them to live in your world, okay, different ways to do that. You know, if you go through and what is it? Yeah, include them in the same folder where your Dynamo script is, you can use them. Okay, they may be a little hard to spot. Let's see if we can sort of figure out where they are, because build all that's in there. Here's what we got to do. We got to take these custom nodes and ultimately sort of publish them so they show up in the list. Let me kind of show you how that works. So come back over to the main one. This is almost what we had to do when we downloaded some packages from the external world. So over here in Edit Custom Node, and there's some custom node properties. Okay. You see we have, the description of what it is. Okay, it has a name, grid manipulations. That's looking pretty good. If you want to go ahead and description must be longer than 10 characters. This is how we would actually publish it to the entire world. We could publish the Dynamo package. Okay, so this node mirrors a grid of points vertically. I can give it some number like 001 since it's really kind of a brand new thing. I can say publish it. When I say publish it that way, I'm basically putting it out in the world. It's putting it out in that shareware source so other people can download it, stuff like that. Okay. If you want to publish it that way, you can. The other way to do it, though, is, let me try this in terms of packages. No, those are some ones that I have there. I'm trying to see, there, well, no, it actually did show up now, down there. Okay. It's funny, even though I did, it's funny about this whole thing about publishing it or not. Let's see if we can make this work again in terms of what's happening there. Let's go back over to, right now, mirror verticals over there. Let's try mirror horizontal. Again, edit the custom node properties. Say OK. It's still not kind of hanging around in there. Oh, there it is. It's really just as soon as I edit the custom node properties, I can get it to go through and show up here. It's really just kind of refreshing this list. So if it isn't showing up in your list, go ahead and select it. You can kind of get it to show up over there. But by putting it over there, then you'll get it to show up in the list, so that when you type in something to search, it'll go ahead and match against that. So see if you can get those little nodes to show up for you. And if you can, we'll go ahead and just finish wiring this thing together. Okay, so let's pause for a second. The whole notion of doing a custom node kind of makes sense. Okay, input, output, not too bad. Great. Let's talk about how we can use that then. As you work along with all this stuff, you're just going to start to want to give yourself the ability to go through and create different sort of switches that turn on and turn off different behaviors, because you want to be able to control what happens based on what kind of geometric transformations you want to create. So we have this kind of function all set up right now. It's going to go through and push some values through. If we want to be able to say that, hey, let's go ahead and grab, some list of values and really control whether you want it to be mirrored or flipped or really whatever it is, how we could wire that together. So here's basically the issue. We're going to use a series of if functions to go through and apply some different tests and return one thing if true, return a separate thing if false. Okay, so not too bad. And to do that, we're going to set ourselves up with a couple of different little variables. Little booleans, one called mirror vertical and one called mirror horizontal that you can turn on and turn off. So it's just always going to return true or false. So how's that going to work? Okay, if we want to control the issue of whether the thing should be mirrored horizontally, what we can do is do this. We'll take that boolean and make it the test. Okay, we have two different options now. In terms of what we're going to pass downstream, if we want it to go through and, if it is true, pass the mirrored list, what we're going to do is hook the result of mirroring the grid as the true function. Okay. If we want to also offer a false option, that is, pass something down that isn't mirrored, what we can do is actually just grab the contents of the image file and pass that directly. So it's really just it's kind of like bypassing. So if true, pass. If false, bypass. Okay. And now the result of that will always be, just depending on whether it's mirrored or not, okay, give you a different result there. Okay. Let's check it out and see how it works. So for example, I'll put the watch in there just because I like to kind of take a look at this stuff. Let's pass it the result. Okay, let's see what's going on right now. Let me set mirror horizontal first to be false. It's doing a little run in. Probably still got the 20 by 20, which is probably a little more data than we want. It's still working. You good now? Okay, there's my little 20 by 20 grid. Oh, it's not hooked any color values yet. It's just kind of doing that now. Okay. So, for the sake of making that a little bit better, I'll make it like 5 by 10 or something like that. So what we are going to do is check it for whether it's mirrored or not. That's another picture of Trixie. Okay, so this is the unmirrored version because mirroring is currently turned to false. If I go through and look at the values from the image file, let's see if we can just go to test this out. I'll put another watch in here. Okay, hopefully, since we aren't mirroring, these two values or lists are going to look just exactly the same. Looking pretty good. 48, 64, 51. Okay, looking the same. No mirroring. If I want to go through and turn on the mirroring, just go ahead and flip the switch. Rerun it. Let's see what we got here. Okay, so for every different little subset, 64, 48, 128. Yeah, you can see it sort of flipped the whole order around. Okay, so it has mirrored it right now. I'd have to kind of break it into the grids to actually sort of think about what the order of the points is, or break it back into the rows and columns. In a similar sort of way, yes?
Sorry, what does it mean whenever it doesn't even give me the option to run it? Like it's just gray and it doesn't let me click on it.
Usually what's happening is there's something happening over in Revit that's just sort of holding it. It doesn't think that like it can continue. So check out in Revit. Every once in a while though, what happens is it'll just crash. So then what I do is close it out and reopen it. But if it's not even available, it usually means that this Revit's kind of hanging up. Let's check in with other folks. How's it working for you guys? Generally kind of okay? Able to kind of run this thing? Okay, let us try then. Just hooking together the other piece of the logic. Okay, so we have the whole choice. If mirror horizontal, then go ahead and pass something all the way through. Okay, if pass that through. If we wanted to give you the option of basically either mapping horizontal or mirroring horizontal or mirroring vertical, we could just set up two different ifs. And that's what this little red if node off to the side here is doing. It's basically just saying it's giving us the option of taking another input. That's going to be our test over there. So how will this work? It's going to look as follows. If we want to go through and mirror it vertically, what we're going to do is pipe the result from the prior function through this and pass it through as the true. If we don't want to mirror, we're going to take the result of the prior and just pass it through as a false without doing the mirroring function. Okay, so that'll look like this. We'll say, hey, let's take that old result, and if no mirroring, just pass it through directly. If you do want to mirror it vertically, we'll pass in the list and basically pass that through as the true. Okay, and now we got a result. Okay, and hopefully that result Let's see, what are you complaining about? Test input must be connected. I think you are now. Oh, maybe it wants the result of something. Okay. What we're going to do at the tail end of all that is, for example, change the color values. Let me try just watching this one and see what it's returning. Okay, so it's returning that. The fact that that's currently showing up red, I think of that as just being, I think that's an error in Dynamo right now in terms of what's going on, because it is passing the values through. And then I can take that result and pipe it into the color override function. So let's see how this all works and see if we can make some sense of it. Okay, so let's turn them both off first. We'll see how this works. I actually got a couple different things in there because there was the more finely grained one as well as the one that has the smaller number of points. So I'm going to take them all out again. And ever since Natasha said that, I really have been wanting something that just lets me clear out old geometry. I want a little purge function that can kind of let me do that quickly. So let's see what this looks like. Okay, again, it's pretty coarse right now. We can turn it up if we want to. Right now, it's not mirroring vertically. It's not mirroring horizontally. Let's check this out and see if we can make it happen. The theory is that if I say mirror horizontal, like the purple is going to flip over to the left side or something like that, or this very strong purple with the green will flip over to the right side. Okay, let's give it a try. Actually, even turn on run automatically, just so that it'll be easier to watch it happen. So flip it horizontally. That's interesting. It didn't, although, okay, this is exactly, I think I had the vertical and the horizontal flipped around. Let's take a look at this. Always confusing me. Let's try this again. So if I say mirror vertical, is it mirroring vertical? It's a little hard to tell in terms of what it's doing right now. Okay, now that I can see. Okay, that is definitely mirroring vertical. So what's happening is, if you look at this big block of the 7 white cells, they're going to flip up to the top. Okay. Okay, in terms of horizontal, that's a little stranger about what's happening in there. I'd like to think that's all working in there. I think, let's go ahead and even turn up the number of points, though. That might actually help us out a little bit in terms of seeing what's going on here. Let's say 10 by 10. Okay. And again, let's try mirroring horizontal. Okay, I think it is. You're seeing it now. It's a little finer grained in terms of what's going on. So if you follow like this little purple, brown, brown, it's kind of going over to the other side. Okay, same thing over here. This little like dark dot, dot, black, black, that's flipping over there too. It's kind of funny, when it's too coarse grained, I can't really see it very much in terms of what's going on there. Just to bore you all with the final result. Let's go ahead and just do it at 15 by 15. Still not very fine in terms of what's going on. Yeah. Oh, still doing some work. There we go. Oh, it's interesting. Okay. Can you almost see Trixie there now? Okay. So what is happening to her? It looks like relative to the way her image should be, it looks like her ears are pointing down. She is facing to the right. Okay, but her ears are pointing down. Okay. So that gets back to, Trixie would be very honored if she knew that she was going out on YouTube. Okay, so yeah, so flipping horizontally is the right thing, but flipping vertically, we do want to flip that around. Okay, that's looking more like her right now. Okay, so that would feel good. Okay, so the whole point of all that really is that, you know, A, the kind of cool thing that you can map all this stuff is fun, but the more important thing is B, hey, these functions get to be really, really useful. And as we start sharing functions and building up, you know, Zach Cron, he shared that really nice function that took all these XYZ points and returned them in grids. You know, super, we want that. You know, we're going to start creating our own little functions and kind of share them around, doing things like that. And just now we'll start just building up a whole open source community of functions that we can start sharing. Okay, so big thing is build these custom functions, you know, to kind of make your life a little bit easier. And then be thinking about this whole notion of X, Y's and really how, or Booleans, excuse me, and tests and really how you can start to use those to control different things. Like, so far we're just doing it to control some specific features. We're about to kind of look at an example where the geometry will get pretty complex. So we're going to do that same sort of thing with the Booleans and an if-then to control, you know, is the Revit geometry going to build? Or are we just going to be playing around in the geometry? You know, are you going to really build the true Revit elements, or are you just going to play around in the geometry? Because sometimes it just takes a long time to generate all that stuff, and you want the ability to kind of turn on and turn off different parts of the equation. Okay, let us close out that one. I will just finish this first half of the session with just taking a look at this one other script that I think you'll need, but it's kind of a very basic script. I think you'll get the hang of it pretty quickly. In terms of under 9.3, it's the whole notion of really converting things into brightness values. Let me just start with that one. And the idea is after you've made this list and you've transposed it and you flattened it and all that kind of stuff, and I could now, since I have those new functions, even straighten out this example so it doesn't have all the transpose and flatten. I can just sort of say flip it horizontally and leave it at that. Oh, it's generating right now. I should turn that off. Or I should put a nice if then in so I can actually control that. Okay. There are a couple functions, though, that'll let you take a list of colors and actually evaluate numeric values out of them. Because colors themselves are just RGBs. It gives you these 3 different numbers. In terms of then really how you can evaluate it, there's a couple of different things. You can evaluate its hue, you can evaluate its saturation, you can evaluate its brightness. And what those 3 functions do is they try to basically take, let me stop running that automatically right now until we put some better sort of if in there. It basically tries to take some different color values, okay, and return some brightnesses to you. So for example, if I take that list that came out, that flattened list, could have come out of my better looking function, and I go through and run that, what it's going to do is basically just return a bunch of a list of all the different values, really taking all those RGBs and just evaluating them on a scale of 0 to 1. So 1 is probably, interesting, let's check that out. I suspect that 1 is the brightest, so it's pure white, and black is probably 0. Okay, so we can look at them that way. Other ones that are available for you, though, that are also kind of useful, depending on what you're trying to do, are color hue, color saturation. Let's see what color hue does. We're going to basically give it a list of colors. Let's run that. Oh, that's giving us on the 0 to 255 values, kind of really where it's sort of falling, kind of in the color scheme there. Let's try saturation. I think of that as being an intensity of saturation, but again, let's take a look at that. Yep. So again, it's giving us sort of on a value of 0 to 1. Because hue, saturation, and brightness is just another way of looking at colors as opposed to RGB, and we can describe any color kind of using those kind of 3 different variables. So using these, we can return some numeric values, and depending on really which ones you want to use, we can go through and adjust things to sort of use those numeric values. So what I was suggesting for the purpose of the assignment is that brightness is often kind of an interesting one. What brightness is often used for is, even when we do like laser etching or something like that, what we'll do is we'll take color photographs and based upon the black and white version, strip out the actual color, just go by the intensity of the white to dark, stuff like that. We'll etch things into surfaces. Okay, it's kind of a really cool way of just kind of getting 3D photos kind of etched in and kind of creating a third dimension out of just black and white information. Okay, so that can all be done with brightness. To do something like that, all we need to do is take all those different brightness values and really kind of use them to control some value, some instance variable that would let us control the depth of the cut, something like that. So what I was suggesting for the assignment is basically go through and take that brightness value and really just kind of use it to help set an instance parameter. So what that could look like is if we have, for all these different elements that are kind of hanging around in there, and all these little panel elements do have a property called height. I got my old ones in there too. I don't want the point, I want the panel. Okay. Each of those actually has an instance parameter called height that we can actually set that kind of using these values. And to string it together, it's actually pretty easy. What we're going to do is just grab those elements, all those different little adaptive elements that you have coming out when you place all those adaptive elements. So we'll string that in. Oops. As the elements. We'll take the parameter and we'll basically feed it some sort of value. If you just wanted to go through and feed it the brightness values, if you wanted the height to range anywhere from 0 to 1, okay, I could just take those color and brightness values and just feed them in. Okay, but if you want to go ahead and amplify it or give it some minimum thickness, you could go through and put some sort of formula in there that says take the value and kind of put a multiplier on it just to kind of make it more accentuated or minimize it, whatever you have in mind. So that's all this is about, is that you could go through, grab those, just kind of multiply some amplifier to it and use that to set the value instead. Either way. Kind of depends. So a lot of things you can do. This is very much like the drops on the pond or the ripples on the pond. It's the same notion. If you have some sort of wave, if you have some sort of function, just go ahead and kind of shift it and amplify it if you want to. Really. Any questions about that? Because that's all there really is to this whole notion of being able to kind of change the brightness and kind of either emboss or deboss things. Embossing being cutting in with a negative value, debossing being adding a positive value to kind of flip the image. And really in the assignment, what I suggested is that, hey, it'd be nice to go ahead and give yourself a couple booleans to kind of turn on and off those effects or choose which effect you want. Is it going to be an emboss or a deboss? That could be an if, that if it's emboss, it uses one function. If it's a deboss, it uses the other function. Either you're just adding or subtracting. Something like that. So that's sort of making sense? Okay, let us go ahead and break for right now. Come on back in 5 and we will shift gears to something that's actually going to be a lot of fun, which is this whole notion of creating a stadium. Because it's kind of a really cool, very kind of visually impactful and fun thing. So come on back in 5 and we will get started with that instead.